Hey, welcome to Validated.
Hey Austin, I'm so happy to be here again, and yeah, really excited.
Yeah, it's good to have you. Good to have you back. There's a ton that's happened in the MegaETH ecosystem since then. You were, of course, one of the co-founders of the project. So I think before we get into some of like the specifics today, like where is MegaETH at the moment? What's the status?
Yeah, we just launched our mainnet after about 1.5 months in the frontier stage, where we're busy integrating with the projects, with the applications, and now the mainnet is fully out. It's open to any builder to come and to build and to test, and we have a bunch of very interesting apps already launched or coming up within the next few weeks. Yeah, so this is where things are at.
Yeah, you guys made a really interesting decision, which is to do something I don't think any network has ever done before, which is to launch a mainnet without a token, but also to have there be an expectation of a token. Maybe Base is the only other one I can think of, but Base said there wasn't going to be a token, now said there is going to be a token, then said maybe there isn't going to be a token again, so who knows what's going on with theirs. But MegaETH from the beginning, there's a token component to it. So I guess walk me through a little bit like, if the token's not needed now, what is the token needed for?
Yeah, very interesting because we actually planned a bunch of interesting utilities for the token, and it's actually going to be pretty core to our model in terms of security, in terms of the business. And I think the most interesting part will be the integration with the fault-proof system, because with rollups, with layer twos, you need a fault-proof or a validity-proof system, and it costs money for people to run such systems so that they keep an eye on the security of the chain, and it's actually beneficial to every user of the chain. So it's kind of natural that you want some incentivization to these kind of people. So this is, for example, one of the use cases, and we're also thinking about ways for Mega Token to be more useful in the actual, like, the daily usage of the chain itself. I will not dive into details, but yeah, this is what we're looking at. And also to touch on the point of a layer two launching the chain, launching the mainnet without the token. I would say it's actually pretty common to the layer two model, because yes, it is true that on day one, many of the functionalities can go by without the token. Of course, it's not ideal. I think I would say tokens are more like central to the layer one business slash incentivization model.
So, you guys obviously get compared with Monad a lot. I'm not trying to do that here, but one of the interesting components with them was having a network that was in sort of a testnet phase for so long that had real applications deployed on it. I think in some way, in some people's minds, they were like, oh, maybe you don't need a token for a layer one. Like everything seemed to work fine. There was real USDC on the Monad testnet, and, okay. And you look at L2's designs and you sort of say, okay, well, like if these things are central sequencers or even a limited set of sequencers, there's no one who's got a model that isn't basically a proof of authority network at the moment for some type of L2 sequencer. So isn't the authority sufficient if not the token? And then you sort of get into all these interesting questions of, well, what can you do with a token attached to an ecosystem if its function is not to provide economic security, however much of a meme that may or may not be? Some people still believe it's important. So I guess walk me through a little bit. I know you don't want to get into details of like what exactly the token functionality will be, but like broad categories of ways you think the token or might be useful in the MegaETH ecosystem, or at least ways L2s should explore using a token in an ecosystem.
Right. Yeah. So first, I kind of touched on this point on the token helping to incentivize and even just to provide economic security for the fraud-proof system. And same goes for the sequencer. Ideally, the sequencer should stake a bunch of tokens so that it's also deterred from doing any like damaging activity. Second, as I mentioned, day-to-day usage of the chain, we are exploring gas sponsorship in the form of the tokens. So there are many ways to do it, and something that I personally found pretty interesting is we recently supported a bunch of EIPs. We're up to date with regard to EIP 7.2, and we can actually quite easily upgrade people's account to smart accounts, and this allows great flexibility in terms of how you want to pay your guests. And our applications that has launched so far on the mainnet have kind of demonstrated us the good experience if you can have a smart account being central and core to the user experience of the applications. So I think this this broad domain of smart accounts sponsored by MegaToken is definitely something we're going to explore. And I would say also, because MegaETH is as people know, is a pretty high performance chain, we expect that there will be interested parties that want to co-locate with our sequencer, even whether or not it's decentralized, because even if it's decentralized, they may want to co-locate with multiple instances of it, right? So we're thinking about a solution where you can kind of try to co-locate with us while like either stake or spend the mega tokens in that general direction. So this is another concrete use case. And personally, I'm pretty excited about it because we did a lot of debate on whether like low block time is actually good for an on-chain financial system. And our answer is yes, it's extremely important given that you have a good co-location / low latency access infrastructure, basically like what Double Zero is thinking about. And we thought that the mega token is a pretty good economic underpinning for such a.
Yeah, it's kind of funny when you talk about things like co-location, these sorts of things. It seems like the more we advance into decentralized finance, the more core components of centralized finance creep back into the system. Not necessarily in like a bad way, but it's interesting looking at like Arbitrum now has time boost, which is kind of a way to monetize on the way in. They're looking at doing some stuff on the way out as well. You guys are looking at co-location as a core feature. Now, of course, NYSE, NASDAQ, all these venues charge a lot of money for co-location. So it there's at a certain point, like, sure, it makes sense to sort of bring those same type of models in. I guess when you sort of are talking to someone who's looking at these traditional financial systems and they're looking at some of these new systems that are not Ethereum, they're not Solana, they are more geographically bound, right? Even if the sequencer is a totally permissionless operation and there's, two and they're just completely stake weighted, you have to have a certain amount of long-term geographic context for co-location to even become something that someone wants to do. This is part of why Hyperliquid has said, hey, like we're starting and we're staking ourselves in Tokyo, like that, because Binance is in Tokyo, right? How do you think about like the conversation with folks who are both very crypto native on like, no, wait, this is actually cool and interesting, and then on the flip side, in the traditional finance folks you're talking to who say like, well, why would I do this when I can just plop my trade server next to Binance? Like, give me both sides of those conversations about this sort of new generation of blockchain.
My observation is that the more crypto native folks, they are more attached, or they are more familiar with this model of a bunch of micro auctions. Here, micro auctions examples being time boost in Arbitrum. More extreme examples are, say, PBS in Ethereum world, where you can decide how you want your transactions to be ranked inside a block, even to like the individual level, right? Yeah. I think for Arbitrum, for time boost, is more on a certain microscopic time periods. I feel that people are inclined to take on these microscopic auctions mainly because it has been a model for Ethereum for a long time. But yeah, so I'll just first state my observation and then provide my opinion. On the other hand, if I talk to more like traditional finance people, like with that kind of background, especially market makers who do both crypto market making and TradFi market making, I think they are more open to the idea of the crypto world doing this low latency, ultra optimization like people have been doing in traditional finance, because I think they probably see the value of ultra low latency infrastructure. It provides in terms of improving market liquidity, improving the spread, improving market efficiency. So yeah, I sense these two general like different camps of people with strong opinions each. So my opinion on this is I am kind of a firm believer in minimizing latency. And I do think microscopic auctions has to be either replaced or quote unquote upgraded once we move to this low latency operating model. So if you think about, say, Ethereum, they can afford to do microscopic auctions like PBS because you have a 12-second slot. And to actually for distributed players to agree on whose transaction should be ordered on top in front of whom else, it's quite some computation and coordination. And it's exactly because you have 12 seconds, and I think in particular 4 seconds within the 12 seconds period of time to actually agree on this kind of stuff, that you can reach like a working market. And if you try to push down, say, the block time, for example, of Ethereum, while trying to maintain this microscopic auction model, I think problem will arise. Because, for example, if you go down to, say, 200 milliseconds of block time, then someone, and suppose that the next block builder is going to be in New York City, then someone in Tokyo may not even have the time to signal his or her willingness or his or her willingness to pay in this auction to the host of the auction, which is the block builder in New York City. So these kind of issues, they arise, and you'll be forced to co-locate people to shrink the physical distance so that you can still run these auctions at a high frequency. So basically, my opinion is that if you want to push down block time, which I think we should for market efficiency, you end up having to co-locate people to either maintain the granularity of the auctions, which again is good for market efficiency, or you extend the duration of the auctions. Basically, you tell people that, okay, I'm not gonna swap who has the rights to low latency access to the block builder. Every block, I'm going to do it every week or so, and it's probably also going to be fine. But still, the kind of the realization is that we have this problem, and we either solve it by this co-location model, or you have to solve it anyway by people voluntarily co-locating with the block builders. And we thought it's probably much better if we just formalize this arrangement and do a co-location service like officially.
Interesting. So like when you think about co-location, so we've like one of my whole like long-term theses of blockchain is we're moving from a purely ethereal software world of like, oh, isn't the EVM a nice idea? And it just runs on the concept of computers to like, this is MegaETH. It runs on this server, in this rack, in this data center, and it's got cables connected to all these other folks who have chosen to co-locate. The minute we get into like the lower down we get, the closer we get to like the actual bare metal, and the more that matters, the more that some of these ideas of decentralization kind of have to change. We go from the concept of Ethereum being ethereal, right, to use an actual term for it, to like MegaETH is a machine somewhere, or 4 different machines somewhere, but like a fixed quantity. Even Solana, right? There's 1,000 servers that run Solana. That is still a large number, but like there are somewhere like a very small cluster of computers that run Binance. There's a small cluster of computers that run Hyperliquid. There's going to be a small cluster of computers that run MegaETH. I guess, how do you think our understanding of decentralization should evolve? Because there's been a lot of, I would call it like armchair philosophy decentralization for a while, that sort of like, this is conceptually good. And you get into sort of very arguments that sound very similar to like, democracy would just be better if every citizen had to vote on everything. And then you're like, well, like the vast majority of things nowadays require very specific knowledge that the average citizen does not have. And like, maybe it's good that we have like professionals in the DoD deciding what weapon system we should buy, as opposed to just a bunch of people voting on what weapon system we should buy. So like walk me through a little bit of your thinking around decentralization, and what is important for MegaETH to maintain, and what is kind of just detritus that you can push away.
Very interesting question. Yeah, and I do echo the point on not all democracies need like direct democracies. I am I wish for a world where people can have, where everyone lives in a direct democracy, but it's not. I mean, I'm not diving into it, but it's also not very practical. But anyway, on blockchain, so I think we should. Okay, so the guiding principle for us is to decentralize trust. I think this is like the single most important value proposition of blockchain of any form, layer 1, layer 2, various blockchains, right? So decentralization of the trust. MegaETH is going to push for it. Absolutely no question.
And what does that mean specifically for you guys?
So, yes. So let's take an example, right? The sequencer, once we fully build out once we fully get on board this permissionless fault-proof system, the sequencer does not need to be trusted. If the sequencer does something fishy, it can be kicked out. It can be proved. It can be proved that it has done something bad, and nobody's money is at stake just for a rogue sequencer. So I think this is one example of decentralized trust in the sense that you don't have to trust any single party in this game. So I think this is paramount, and absolutely no sacrifice can be made for it. On the other hand, the way you achieve decentralization of trust has historically been the decentralization of operation or decentralization of the physical assets. And that, I think, is only a means to an end, and at least have a bunch of wiggle room. So I think you made a good example on Solana running, say, on 1,000 servers, which is a different number compared to Ethereum, which is again different number compared to other layer ones, especially the more upcoming layer ones, right? So I think people are already like playing with that dial to explore different trade-off points. And to me, layer 2s are just yet another point on this trade-off curve. So again, to recap, I think decentralization of trust, like minimizing trust on any single party, absolutely necessary. I think this is why people are willing to put a bunch of money on blockchains without really like doing due diligence or doing significant due diligence or like talking to the founders themselves. On the other hand, how you achieve that, I think that's actually the crux of the problem. And my potentially unpopular take is that actually much harder to build a layer 2 than to build a layer 1, because I would say throwing machines at your problem, like throwing decentralized assets, physical assets as the problem, is one of the easier solutions to the problem, and actually trying to operate based on a smaller number of servers while still maintaining decentralization of trust, that's actually pretty hard.
It's hard because of the performance metric L2 is trying to hit.
Well, it's hard because you binding fault tolerant problems, binding fault tolerant consensus is a well-studied problem. And I did my consensus research for quite a few years, and realization I came up with was that I think after 2022, all new consensus algorithms are just like recombination of existing ideas and the tweaks of parameters. So it's a well-studied field, and you can run, say, 1,000 servers in Solana's case, and hope that not more than 1/3 of the servers goes down or goes rogue at the same time, and your problem is solved. It's a clean solution to the decentralization of trust problem, but still you are running 1,000 servers, right? So for rollups, for layer 2s, you don't have the luxury or the desire to run that many servers for different reasons, for example, performance, right? So you have to make sure the code you run is correct or is attributable. So one concrete example is we know that we have fault-proof systems, right, for layer 2s. What if there is a software bug in the smart contract or the proof system that arbitrates if a fault proof should be accepted and thus penalizing the sequencer or not? If there's a bug there, then either a bad guy can misattribute a good server, or a bad server can escape attribution. So I think these kind of issues, it kind of ties a lot to formal verification, to how do you make sure your software is correct, right?
Yeah.
I think, so for example, even on airplanes, they, I think, run consensus algorithms among, say, important sensors. And I would say this is also like you're throwing resources at the problem, which I think in the case of an airplane definitely is worth it. But
Yeah,
I think in blockchains,
I think an A350 has 2 redundant sensors and then 3 redundant computer systems that often have their own redundant sensors just for like basic flight operations.
Yeah, because I think actually planes have crashed because multiple redundant sensors, attack of angle sensors have been frozen at the same time. It's actually horrible. So for planes, definitely worth it. But I think for blockchains, I guess what layer 2s are trying to explore is if you can minimize redundancy while still achieving the same goal of minimization of trust. Yeah. So basically, you have fewer resources at hand to solve the same problem. So I think that philosophically is harder.
Yeah, it's kind of funny when you talk about the airplane example. One of the things I have often wondered is fraud proofs are an ex post facto catch.
Yeah.
Right. So like the beauty of blockchain consensus in most BFT systems is the item is not considered finalized until it has passed a certain BFT threshold.
Yeah.
Right. And that threshold differs on different chains, right? On some chains it's like 7 nines, and subchains it's less. There's nuances there, but either way, there's like statistical checkpoints that as a user, if it's X deep in the block, it is Y difficult to unwind or Y impossible to unwind. With fraud proofs, you don't actually have that assurance until the proof is generated. And then also from what I can tell, there's never been a situation where a fraud proof didn't pass check. But also in protocols that use DA layers, 99% of the time, there's no read on that DA. Like the fraud proof, the people just look, is there data where there's supposed to be data? And they say, yes, there is data there. That data could just be the collected works of William Shakespeare, serialized. Or it could actually be the call data that's supposed to be associated. And so I kind of wonder, like, when you think about this, do you think our current systems are actually sufficient to establish trust? Because there is no active affirmation of trust in an L2 system. There's a ex post facto or a secondary catching or something along those lines.
Well, so I think you touched on multiple attack vectors. So it's a very interesting question. Yeah. So let's go with the DA question first. Do DA actually make the data they claim to be readable? I think this is the same question as, do layer 1 validators actually validate before they vote? Because I would say validating high performance layer 1 blockchains is actually a costly job. You have to maintain lots of states in RAM. And if I am a unresponsible validator, I probably will just follow what other people have done. And if they vote, I vote.
This was a whole problem in Solana for a long time. There was something called vote lagging, where folks would just wait to vote until they saw what 66% of the cluster looked like, and they would vote that way. Because then there's no risk.
Yeah, exactly. So I think the same risk theoretically exists for DA layers as well. So basically, my mental model for DA layers is that it's just, I think it's kind of a subset of the features of the primitives provided by a layer 1 blockchain, but not too different. And so I would say that like the attack vector, like negligence risk is the same, I would say, on DA layers versus layer 1. So I wouldn't really highlight that problem. Yeah. And on the other hand, on fraud proofs, so I think there was one small mistake, which is you can, of course, wait for the fraud proof window to expire. And basically you have to set a threat model in your mind that if nobody raises their hand for 7 days, then it means that it's kind of implied that this block is fine, which is not the end game. I can be very clear, but it works. So it helps people bootstrap their trust. So I touched on the topic of endgame, and also you asked if fraud-proof system is really sufficient to bootstrap trust. I think yes, because if one looks at the TVLs at those leading layer 2s, rollups, it's decent. And most of the high TVL rollups / layer 2s, they are secured by fraud-proof systems. So I think it does bootstrap trust. But is it the end game? I wouldn't think so. I think the end game is very simple. It's real-time ZK proving. So once you have a new block produced on your layer 2, a ZK proof is produced for it within, say, seconds, tens of seconds, and that just positively affirms the correctness of the block.
Let's take like the co-location thought experiment a little further, right? Because the way this is handled in an airplane, right, to go back to this analogy, is you have multiple inputs, sometimes redundant inputs, but let's just take the simplest system where you have one set of inputs and they run into 3 different computer systems. And if those computer systems detect a difference, right, if 2 of them say, oh, the flap is here, and one of them says, wait a minute, what about, I think the flap's actually here, that throws up some sort of error flag. And, step 1 is they kick that computer off. Step 2 is, you figure out, okay, well, if now both other computers diverge, we have a different set of problems. But this is a concept that actually TradFi has used for a while too, which is the idea of like every time a TradFi server makes a trade, there's a copy of it sent to a compliance server. And that compliance server does 2 things. One is it validates that like, hey, I did mean to make this trade and the trade did happen. But the second is it's to prove to a regulator like, hey, we did this trade at this moment. Here's why we did this trade at this moment. There's a bunch of national market structure and legislation that is not worth getting into. But it's kind of one of those interesting things where the minute you're talking about co-locating sequencers, you could simply multiplex the data coming into those sequencers. And you could sort of say that like, oh, MegaETH Labs is running one sequencer and I don't know, pick your company, TRM, Coinbase, Binance, whatever, is running the second one. And then you have an active flag system. So I'm kind of curious when you sort of look at these types of systems, like, since we're already getting into the realm of co-location and, pay for access to these sorts of components, like, is there a reason in your mind that you think for like the ZK proving work is going to have a higher degree of trust than sort of co-active equal systems?
Interesting. I think it's for different audience. If you are a big user, if you're a big consumer of blockchain assurance, you can always run your own node and you can validate it just by I think that, the benefit of the ZK proof system is always for you to have this asymmetry between the work of generating the proof to the work of verifying the proof. And one proof works for an endless number of audience, which is great for, say, retail and consumer users. But if you are a trader, yes, nothing prevents you from running. Actually, we already have this kind of setups running internally. You can have stateless verifiers that verifies incoming blocks in real time, like absolutely no performance penalty. And this would be great for active traders, for example.
Yeah, interesting. So like in some ways, one is for like, I wake up tomorrow, FTX 2.0 is imploded, and I really want to make sure that my balance on MegaETH is still there. And that's what a ZK proof is for. Whereas like, if I'm a trader and I'm, and I think I got my order in, but actually the market maker got their cancel in before, like the second one is basically to give me confirmation that no, like nothing funky went on in the sequencing. There wasn't a packet maliciously dropped on its way into the sequencer or something. Like the outcome was actually indeed verifiable.
Yeah, exactly. That the sequencer, when it tells you that your transaction actually went through, it went through, and it will stay in that state when it's like the state is persisted back to the layer 1.
Right, because this is always the challenge with like even ZK proofs and fraud proofs is there's no recourse there, really. Like at the end of the day, if something told me I was included and I wasn't, it's great I have a proof that I wasn't included, but like I still got liquidated or I still lost out on the trade. And it's not like what happens in the traditional space is you take your ticket and you go to the exchange and you say, hey, something happened, and maybe there's a lawsuit or some restitution that gets involved or a settlement or something. But like, you can't really sue the sequencer. You can't go to the sequencer and say, hey, like, go change the order book. Here, I should have gotten it.
Yeah, right. Yeah, it's exactly the case. And it's actually pretty interesting to me. I'm personally very, very curious if market makers run a similar setup for, say, layer 1 blockchains. Do they actually run their own validators? That's a big question to me because I know many players, I know many who prefer to run their own node, but I also know many who just want to use RPCs.
Yeah.
And RPC is absolutely a trusted component in this chain. So yeah, well,
I mean, I'll tell you, there's plenty that go even further than that, and they actually proactively collect block data from multiple points all over the world, so they can try and reconstruct what the block looks like before it's even been voted on.
Yeah, I think that's definitely the more professional,
Yes.
more well, resilient
I don't
way.
think Ansem's out here collecting fragments of block data from around the world, but maybe the Cumberlands and the DRWs and the Wintermutes of the world are. Yeah. So I wanna get to some of like the value propositions for MegaETH, because we've gone from a world that 2 years ago there was really only one high performance blockchain that was live in production. There was Solana, to a world now where we have many, and they have many different flavors of what they're used for. Obviously, Hyperliquid is a product that's very focused on perps trading. But then we also have a bunch of, other L2s and L1s that have launched. So the idea of like, we're going to launch a blockchain, it's going to be super fast, and that's going to be its core value proposition. Like, the world has changed in the last 2 years. So what do you sort of look at as like the characteristics of Mega that make it attractive for the types of developers you're trying to attract? And how would you set it apart from some of the other solutions out there?
Yeah, interesting. So I will try to answer this question more on the technical side. I think so yes, I think people have caught up in this high performance blockchain like narrative slash like sector. I still think that we are an innovator and we are a leader in performance and also just performance engineering optimization and coming up with new standards to help users better exploit the performance. So
yeah, certainly. Sorry, just to clarify, not that you guys aren't doing cool stuff. But we're talking about differences in degrees now, like maybe 1 times faster, 2 times faster, not sort of the 20 transactions per second to like 2,000 transactions per second jump like we were seeing maybe 3 or 4 years ago.
Yeah, so I think the first mover advantage is there because we have accumulated a bunch of very interesting apps already that are purpose-built for high performance. And I think we are thinking one step ahead compared to other ecosystems in terms of what you can actually do to make it easier to make use of high performance. It's even different from, say, what Solana has been doing. I think in its ecosystem infrastructure providers, like high performance node hosting and stuff, I think layer 2s are different model and things have to be explored again from the ground. And internally, we are doing exactly that. And for the apps who work very closely with us, they are already seeing either our help in optimizing performance, in optimizing the RPC usage, or even purpose-built APIs for high performance indexing. And I think one interesting example is this globally distributed RPC we built based on Cloudflare. It's almost entirely stateless and highly distributed. Almost all the computation happens at the edge in one of the, I don't know how many hundreds of data centers Cloudflare has. And the single source of truth is this block witness data that helps edge node re-execute transactions to produce tracing details to answer RPC requests, flowing from the central sequencer to the edge of the network. So I think this is one example where we are innovating not only on the chain side, but also to make it actually practical for people to come with their AI buddy or not to build interesting applications and to also try to say market make and profit from a high performance chain. Less on the technical side, as I mentioned, I think a community and a cohort of applications with performance optimizations from the ground up. And also I think we kind of pioneered this model of incubating apps and kind of guiding them, like mutually guiding each other through the development process. We actually took a ton of advice from our app builders in terms of what features we need. So we're really grateful. So that's reason I said a mutual guidance. I think this model worked out well. And I think this is one other example. Yeah, and well, also some interesting stuff we're cooking that I cannot expand on, which hopefully will actually make it even easier for apps to attract users
Interesting.
and get a good experience. Yeah.
So you want to go into some details about what those are?
Probably not today, but in a few months. Yeah.
All right. Okay. On that topic though, I think there's a real debate in the crypto space now, especially among folks who are building new layer ones and layer twos, about how heavily and how prescriptive do you get involved in your ecosystem. I think you see some protocols that have taken a very hands-off approach. You've taken some that say, like Aptos and Sui are two examples of we're going to explicitly and directly develop first-party products that launch their own tokens and, sort of build and exist in the ecosystem. You kind of have the Solana approach, which is like somewhere in between, where it's like we're not going to build and launch stuff ourselves, but we're going to build a lot of fundamental tooling and sort of we're going to be opinionated on what are some of the best solutions at times. And then, you guys have kind of, I think, carved out your own lane, both in you were early to the sort of, I believe the crypto native term is protocolizing and the non-crypto native term is nationalizing a stable coin into the architecture of the system. Like, walk me through how you guys landed at the space you landed and where you draw the line of like, this is too far one way or the other.
Yeah. So, okay. That's a very good question. And I don't want to speak on behalf of my colleagues. I think each holds a slightly different opinion. But my personal opinion is you don't want to kill the creativity of your builders. And so I think one interesting model is Apple's ecosystem. I kind of realized this pattern a few years ago that Apple has this open ecosystem of apps and the App Store and WWDC giving students scholarships to come to Cupertino and all sorts of interesting apps. And then I think at some point, probably 2015, 2014, they started to like copy ideas from its ecosystem and putting it into iOS. And I have to admit that I love using first-party apps just for the better system integration. So usually when there's a competition between third-party and the first-party apps, I choose the first-party app. I think it's kind of dangerous because especially for a early-stage ecosystem. And I'm not saying that if MegaETH ever gets sufficiently big, we'll get cocky and start to like copy people's ideas and just really like quote unquote vampire attack it on your own apps. Sure. Right? I'm not suggesting that we'll do that, but I'm saying that Apple is big enough to do that. And I think for any early stage ecosystem, which to be honest, I think every crypto ecosystem is quote unquote early stage. Yeah. I think it's kind of suicidal to me. So lots of thought has been put by the team to really think of a way to nationalize or to cut a fair share from this value chain that is not hurtful. And I think actually things can be done optimally. For example, stable coins, right? There are some, just if you look at countries, there are some industries that are better nationalized. Even in the USA, I think some of the stuff, for example, the military or maybe the US dollar, is controlled by the government. And it makes sense because you have the economy of scale and you do need some endorsement or some brand image carried by the chain or by the country to do certain things. And we think that some things that individual app teams, third-party app teams cannot necessarily do themselves, we can do them. And we try to stay within the limits that we only profit from these kind of sectors. And so that's kind of the guiding principle that we, of course, I mean, as a chain, we have to survive, we have to flourish. Yep. So we have to take our cuts. But we really think that we are really spending a ton of energy trying to think if there's something that is better done by us, and then we happily take it, right?
Yeah. So like, let's say, so first off, like, I think that's a super interesting approach. I think it's worth like diving into a bit. I want to look at something like the stablecoin because I think a classic view of this would say there's actually a pretty healthy, robust, diversified stablecoin ecosystem out there. Like, I don't know exactly what you guys can add to a new stablecoin or what, Hyperliquid can add to a new stablecoin. But that was a key part of your guys' like ecosystem launch strategy and decision. So I guess maybe like that's a good example here to pick on a bit because, there are things where you could say, okay, we're going to build a super high performant club that utilizes all the special sauce we've added to Mega. Great, cool. I totally get that. A stablecoin to me almost feels like it doesn't fit into that framework as much. So walk me through a little bit around that.
Yeah, so my justification, I think mostly on the UX side, I hate fragmentation of liquidity. Yeah, just because I recently went through the mainnet launch, and you don't have to ask me how good a experience I had with like managing all the liquidity path.
Sure.
It's a mess. So the more stable coins you have on a particular ecosystem, the more mess, like the more conversions you have to monitor your AMM pools if there's sufficient liquidity for people to swap large amounts from one stablecoin versus another. Add a bunch of stablecoins, and the number of pairs is quadruple, right? It quadruples, and you quickly park a ton of dormant liquidity just to maintain like easy conversion between those stablecoins. So this is just one example or one downside of an ecosystem not being able to centralize philosophically onto one stablecoin. Yeah, and also another motivation, which is probably from the business side, I would say each app team probably has their preferred stablecoin provider out of business interest, out of personal preference. And I just don't see a world where we can go like host a congress and tell people, okay, let's figure out the one true stablecoin the ecosystem is gonna use so that our users and our operators do not suffer. Not gonna happen in my mind. So might as well like dictate, for however much I hate the word, a stablecoin. And I guess on the business side, us picking a stablecoin and potentially pocket the rewards coming from the stablecoin, coming from the TVL, that part is actually not novel because I'm very sure many ecosystem cut deals with big issuers of stablecoins. So I think we added a bunch of flavors, and I think we had a very, very strong justification for it.
Interesting. Yeah, I think there's kind of a one of the fun questions, and you don't have to answer this, is like, if we were back in a 0% interest rate environment, would you still have launched a stable coin?
That's very interesting because I'm glad you asked the question. Well, I would say chains or financial systems, they make money in two ways. One is dormant or static money, money that people just park there, and the other is through trading volumes. So for trading volumes, we make from the colocation, and for dormant money, you make from the stable coin. So we're actually hatched.
It's kind of interesting to look at like what are ways that this has always been like the curse of crypto is that like in a true beautiful sense, the fact that there's no dilution is incredible, right? Like it's this like the number of times I've invested in equities companies like super early, get a good ownership percentage, and every time it's like, ooh, I gotta put 20% more in, or I'm gonna lose 20% of my shares, because of dilution, because some of these are very capex heavy companies. The beauty in crypto is we don't have that. The downside in crypto is you get to a certain stage of a protocol where you're like, well, look, the foundation we've just sold most of our tokens, and it's hard for something to continue operation. So the idea of sort of a stable coin that delivers some type of yield back to the protocol team is like a very interesting way to look at like, oh, can we fund ongoing operations in ways that don't actually cost users anything, because every stable coin, you're giving up some amount of yield for that product.
Yeah, that's totally true. And well, I think especially for a layer 2, which I said is actually harder to build than layer 1s, you need to worry about your long-term viability. It's also the responsible way to do things, I think, for users and developers.
Do you think inflation is more or less tolerable on an L2?
Of tokens? Of
Yeah.
native tokens? Well, I don't have a strong opinion because my view of tokens is that, like, it's pure utility. And if the way you plan to add utility to our token requires you to do an inflationary token, I see absolutely no reason you should be worried for, even if you are layer 2. Yeah, that's the way I would put it. I feel that probably this kind of mental model comes from the fact that, again, for layer 1s, you need consensus. You need to reward people from day one. And the most obvious way to reward people is to print new tokens. Because otherwise, so if you tell people that, so my layer 1 token is not inflationary, and while telling people that my network can run for eternity, like for run forever, then people probably are not going to buy it, except for Bitcoin, which I am worried.
Sure. The security budget people are not wrong. They're just a little early for us to worry about it.
Yeah, exactly. So,
eventually the sun will enlarge and eat the earth, but it's not something we have to worry about right now.
Yeah, exactly. So, I think the same story applies to other layer 1s. If you need people to constantly burn electricity or just burn RAMs and burn CPU cycles to maintain to validate.
Right. Or chew through NVMe every 6 months. Yes.
Yeah, exactly. Yeah, the node hosting my Mega, my server hosting my Mega node is down to 57% of health. It's a data center SSD. I'm so sad. And now SSDs are expensive. But anyway,
I know you kind of wish you just bought enough RAM to store it all in RAM.
Yeah, I think the RAM I bought in 2020, I think it has quadrupled. But yeah, so I think it's more like that's layer 2's the security model do not require mass participation from day one, that give people this impression that for the utility of tokens on layer 2s, they do not need to be inflationary. I think it's correlation. It's not causality. And even the correlation is temporary.
So we've talked a lot here about the need for higher performance systems, the ideas for co-location, the ideas for all of these types of systems. But you kind of look across the landscape of crypto, and the units of time and units of transactions that we're talking about are still quite large relative to that of traditional finance and traditional matching engines. So I'm kind of wondering, when you look at a problem like this, of saying, if we actually want crypto to compete with NYSE and NASDAQ and CME and Nikkei and all these other indices in the world, what I see is we're still very far away from that. That the cutting edge L2s and L1s are talking about 10 millisecond block times. And when we think about matching times at centralized exchanges, those are measured in nanoseconds nowadays. Are we architected correctly to actually compete? Is it just a question of more optimization? You guys obviously must have your sights on a very similar goal of we'd like price discovery to happen on Mega. We would like to pull away some primary trading volume from traditional venues. But you look at kind of the performance differences and what does that look like for you?
Well, if we're going to compete with centralized exchanges, I don't think it's a performance game at this point. If we get down to 10 millisecond block time, I think it's more about liquidity and just people's habits.
Yeah,
I think So I think for price discovery to happen on a particular chain, this is more about real organic user flow betting, making their bets on one venue over others. I think at this point it's more about people's habits. To compete or to compare with TradFi systems, I think we probably need to keep optimizing. And my feeling is that so something very interesting I chatted about with a market maker who does both TradFi and crypto market making. So we were chatting that, okay, so this this endless tracing for low latency. Yeah, what about like down to nanosecond if you are already at microsecond, right? And the person kind of agreed, and we started kind of brainstorming, and we kind of agreed that it might be good to just mutually agree on a jitter. Of course, you have to follow the same distribution, but the same distribution of random jitters being injected to every market player, so that people don't have to really endlessly optimize for the data path of their nicks, DPDK stuff. Why? In other words, the question is, why don't the world just settle on a timescale of, say, 10 milliseconds? Seems good to me. So that has been a puzzle to me, and it's very clear that TradFi has broke that that barrier. It is down to microseconds at least. So I don't have a good answer from first principle. I'm not a quant, and I actually would love to be told of the answer of that question. But I think it's worthwhile, and if for TradFi to do that, and if crypto really wants to, I shouldn't use the word overtake, but to persuade TradFi to adopt its technology, yes, it should keep optimizing. And I mean, how do we get to there? First, I think correct architecture. Wink, wink, layer 2s. Second, just a ton of optimization, and it's doable. I mean, NYSE is probably not too different from in terms of architecture than a bunch of servers doing order matching, but just with a ton of specialized hardware and specialized code. So we can get there. Yeah.
Awesome. Well, Lei, where can people follow your work, learn more about the technicals of MegaETH? Give us some links.
Yeah, just go to megaeth.com, and of course our Twitter. Yeah, and for the mainnet, we have rabbithole.megaeth.com. It's the rabbit hole to the MegaETH ecosystem. Have fun.
Love it. Thanks for joining us today.
All right, thank you so much, Austin. I really enjoyed the conversation.